All right, let's go. Doing some number sense today. Um, I linked a copy of the test in the description. So what we can do is, if you want, you can just tell me which questions you want me to go over, or if there's nothing in particular that you want me to go over, you can just, or I can just start working through. So, actually, I think since we already have some people in, this is new. Um, Usually it takes a few minutes for people to start coming in. Anyway, I'm just going to start working through. If you guys have comments or you want me to do something, then I'll just skip to that. Otherwise, I'm just going to get going. Sweet. Okay. This is just Backpage today, by the way. So this could take a little while, but we'll see. Depends on how many questions you guys have. Okay, let's start. Okay, 35. We have 10 and 1/8 times 8 and 2/5. Okay, for this kind of question, when you're multiplying fractions and there's no like particular pattern, a good thing to try is fraction FOIL, or called fraction FOIL. But because we're doing number sense, we tend to use more of a Leoff sort of setup. So what I mean by that is, first thing you do is you multiply the fractions. So 1/8 times 2/5 will be 1/20, right? And then you multiply the insides and you multiply the outsides. So what I mean by that is, you take 1/8 times 8, you take 10 times 2/5. 1/8 times 8 is just 1. 10 times 2/5, that's 4, so together that's 5. But you have to carry that 5. And then finally we have the fronts, the firsts, so 10 times 8 is 80, plus 5 is 85. Okay, 36. We have 0.053333 repeating. What I would probably do this is I would write it like this. I would just multiply everything by 10 to start with, just because I think it's a little easier to find this fraction. So whenever you have a repeating decimal like this, the denominator is going to be made entirely of 9s and 0s. So the number of 9s is the number of repeating digits. So you can see we just have the 3 repeating. So we have 1 9. And the number of 0s is the number of non-repeating digits. So we can see we just have the 5. Okay? Then to find whatever this is in the numerator, you take the full decimal, or the full number that the decimal is made of. So in this case, it's 53. And you subtract out the non-repeating part. So 53 minus 5 is 48. This gives us 48 over 90, which you can simplify to 24 over 45, which simplifies to 8 over 15. Right? But remember, we have to divide this by 10 because we multiplied it by 10 to get here. So this is actually 8 over 150, which is 4 over 75. Yeah, 4 over 75. There we go. All right, number 37. How many integers less than 35 are relatively prime to 35? Okay, so to do this, you have to find all the prime factors of 35. It doesn't matter like what power they're raised to. All you have to know is that the prime factors are going to be 5 and 7. Okay, and once you have that, you take 35, and then you're going to multiply by these factors, and by these fractions, I mean. And each of these fractions are going to have a denominator that's the prime number, and a numerator that's one less than the prime number. So this is what you're doing, right? I'm taking 35 times 4/5 and then times 6/7. So 35 times 4/5 is 28, right? And then 28 times 6/7 should be 24. Nice. Okay, number 38. 44 base 8 equals what in base 4? All right. Oh, this is a little bit annoying, but it's not too bad. What you kind of have to do is you have to convert this base 8 to base 2. If you do that, gives you 1 0 0 1 0 0. Yeah, 1 0 0 1 0 0, and then convert that to base 4. So let's see, 0 0 is just 0, 0 1 is just 1, and 1 0 is just 2. Uh, 39. 32 squared divided by 16 squared times 8 squared. Okay, so you can, it's not really factoring, but you can kind of factor out this squared term because of laws of exponents. So I'll say 32 divided by 16 is 2, times 8 is 16, and then squared is 256. Number 40, okay, we have our first estimation problem. What I would probably do is I would factor out a 900, and then I have 1095, which I can round to 1100, minus 899, which I can round to 900. So this turns to 900 times 200, which is 180,000. Let's see, 325 base 9 to base 3. Okay, if I convert 5 base 9 to base 3, remember, whenever you're converting these, like when you're going from base 9 to base 3, each one of your 9s is going to turn into 2 digits in base 3, because 9 is 3 squared. Okay, so when you're converting this, you're going to have a 1's place and a 3's place, and you're trying to figure out, like, if I have a 5, then how is that going to work into base 3? So a 5 is composed of 1 3 and 2 1's. A 2 is composed of 0 3's and 2 1's. And a 3 is 1 3 and 0 1's. So there's your answer. 42, it's another factoring one. So I'm going to factor out a 9. Like this. 1591 plus 9 is 1600. And so 9 times 1600 gives you 14400, or 14,400. 43, 36 to the 1.5. Okay, if I convert this to a fraction, it would be 36 to the 3 halves, right? Which, laws of exponents, right, tells you this is the same thing as the square root of 36 cubed. Well, square root of 36 is 6, and then cubed you should have memorized is 216. Okay, 7 cubed minus 7. Okay, and this is in base 7, by the way. So 7 cubed would look like the same way that 10 cubed in base 10 is a 1 with 3 zeros. 7 cubed is also just going to be a 1 with 3 zeros. And then if I subtract 7, and I'm in base 7, that would be like the equivalent of subtracting 10. So, let's see. If I subtract 10 from 1,000 in base 7, I'm going to be left with just this, right? I think that's right. 6660? Yeah. Yeah, that's right. That's right. Okay, 45. We're multiplying two numbers that are close to and over 100. So these are both, so that's 7 above and that's 9 above. So first thing you do is you multiply these two. 7 times 9 is 63. And then you add the two. 7 plus 9 is 16. And then you just write a 1. 46, 20, 23 times 14. You can use what's called the teens trick. Okay? So the first thing you do is I say, I'm looking at 14, and so I'm going to use the 4. I'll say, starting from right to left, 3 times 4, that's 12. So 2, carry the 1. Then I'll have 2 times 4 is 8. And then you add the number to the right of it. So 2 times 4 is 8, plus 3 is 11, plus 1 is 12. So 2, carry the 1 again. Then 0 times 4, that's 0. Plus the 2 is 2, plus our carried 1 is 3. Then 2 times 4 is 8, plus the 0 is still 8, plus our carried 1 is 9. And then I still have this digit right here, technically. So 0 times 4 is 0, plus the 2, plus our carried 1. Wait, no carried 1. So it's just going to be 29,322. Let me double check this one real quick. Yeah, I did something wrong. Oh, I must have carried something wrong. Oh, I wasn't supposed to carry right here. Oh. Yeah, actually, let me just do this one all again to avoid confusion. Okay, 3 times 4, that's 12. Carry the 1. 3, and then I work with the 2. 2 times 4 is 8, plus the 3 is 11, plus the carried 1, that's 12 again. Carry the 1. 0 times 4 is 0, plus 2 is 2, plus our carried 1 is 3. Now we don't have any carry. 2 times 4 is 8, plus the 0 is just 8, real carry. And then I have 4 times 0 is 0, plus that 2. So we get 28,322. Okay, 47. If 6x minus 5 squared equals ax squared plus bx plus c, and then a plus b plus c equals what? So notice if I plug in x equals 1 into this equation, I get a plus b plus c, which is what I want, right? So what I can do is I can just plug x equals 1 into here, right? 6 minus 5 is 1, and then squared is just 1. Okay, 48. The set square, S-Q-U-A-R-E, has how many 4-element subsets? All right, so the way you do this, so this has 6 elements, and I'm trying to find the number 4-element subsets. So in other words, I'm trying to find how many ways can I pick 4 elements out of these 6 elements, which is just a combination, which is 6. That's 6 choose 4, which to calculate that is it's 6 factorial over 4 factorial, and then times 2 factorial. And the reason I have this 2 factorial here is because it's 6 minus 4. The general equation here looks something like this. But basically, one of them is going to be the same as what you're choosing, and the other one is going to be divided by n minus that. So 6 factorial divided by 4 factorial will be 6 times 5 is 30, divided by 2 is just 15. Okay, 49, 13 times 15 over 19. Okay, so the way you do this, I'm going to start here. I'm going to say 13 minus 15, that's 4, and 19 minus 13, that's 6. So, my fractional part, I know this is going to be wrong for right now, but I just have to show it, is going to be 24 over 19, right? So what I can do is I can write 5 over 19 and then carry a 1. And then I say, okay, 15 is 4 less than 19, so I do 13 minus 4 is 9, plus the extra 1 is 10. Okay, we got another estimation, number 50. Let's see, 5714.28. Okay, so you should know that from memorizing that 4/7 is like 0.57. I mean, it's like this, just repeating. And so this number right here is 4/7 times 1, 2, 3 times 10 to the 4th. So if I take 4/7 of 78, 4/7 of 77 is going to be like 44. So maybe I'll bump that up to 45. So 45 and then times 10 to the 4th. So I just add 4 zeros. 51. Okay, I do have to move this around a little bit, but that's okay. So if you have a sum of squares where the outside numbers add to 10, so in this case 6 plus 4 is 10, and the inner ones are 1 apart, so in this case 5 and 4 are 1 apart, here's what you do. You look at the inner ones and see, okay, which one's bigger? So in this case, it's the 65 squared. So from now on, you don't really care about this 44 anymore. So I'm looking at my 65 squared. So here's what you do. You square each of the digits, so 36 and 25, and then you add them. So 36 plus 25 gives you 61. So 61, and then you just multiply that by 101. So that's 61, 61. Okay, 52. 123 to the 19th divided by 7 has a remainder of, ooh, this one's ugly. Okay, here's what I can do. I see what I can do. If I have 123 to the 6th divided by 7, then by Fermat's little theorem, I know that I have a number raised to a p minus 1 divided by p, where p is any prime number. And so I know that this remainder is going to be 1, right? So 123 to the 6 divided by 7, that's going to have a remainder 1, which means if I cube this number and get 123 to the 18th divided by 7, that's also going to have a remainder of 1. And so this problem just simplifies to, right, to find 123 to the 19th, I just have to multiply by 123 one more time. So this problem just simplifies to what's the remainder when 123 is divided by 7. So it looks like that's just going to be 4. Okay, 53. Okay, this is one that gives people a lot of trouble sometimes. Okay, 53. Let 5 and 3 over m times n and 1/2 equal 14, where m and n are natural numbers. Find m plus n. Okay, well, if n, the first thing you have to do is estimate what n is going to be. If n was 3, then you would already have 5 times 3 is 15, which is more than 14. And so we're going to estimate, or make an educated guess, that n is equal to 2. Okay, so we're going to make an educated guess that n is equal to 2, which would make this fraction right here equal to 5 halves. So 5 and 3 over m times 5 halves equals 14. Okay, then part of why this is going to be an integer is that some things are going to have to cancel. I mean, like, some things are just going to have to cancel. So if I turn both of these improper, if I turn this improper, right, it's going to be 5m plus 3 over m. And then this is just going to be 5 over 2 equals 14, right? So I see the only way that this can cancel is if m is equal to 5. And so my m is 5 and my n is 2, and so m plus n is just 7. All right, sum of the product of the roots taken 2 at a time. Okay, for a cubic, this is just c over a. This is just one to memorize. This is just c over a, and so our answer is 12. 55, 4 plus 11 plus 15. Okay, you could just add all these, but you could also notice that this is a Fibonacci type sequence. 4 plus 11 gives you 15, 11 plus 15 gives you 26, 15 plus 26 gives you 41, right? And so on. So, when you're trying to find the sum of a Fibonacci-like sequence, here's what you do. You do 2 times the last number in the sequence, plus the second to last number in the sequence, and then minus the second number. So this one times 2, plus this one, minus this one. So let's see, 2 times 458 is going to be 916, plus 283 should be 1199, minus 11 is just 1188. Let me double check this. Yeah, 1188, there we go. Okay, 56. Log base 5 of 3 minus log base 5 of 8 equals log base 5 of what? Okay, on this we can use some laws of exponents. So if you have log of a, not exponents, of logarithms, and you're subtracting out log of b, you can actually condense this and say that this is the same thing as log of a over b. So in this case, 3 over 8, well, it's just going to be 3/8. A nonagon has how many distinct diagonals? Okay, so you can imagine that for each vertice, right? That's going to be, I have 9 vertices, and for each vertice, there's going to be n minus 3 vertices that I can draw a diagonal to, right? Why n minus 3? Well, because I have the 2 adjacent vertices, which would just make side lengths, and then I have the point itself. So 9 times 6 gives you 54. But then realize that you've overcounted a little bit. So like, imagine you're drawing a vertice and you're going from A to C, right? But you're also counting C to A as like the same, as like 2 different vertices, as 2 different diagonals, I mean. And so in the end, we're going to divide this by 2. So the general formula is going to be n times n minus 3 divided by 2. Okay, 58. If 1 minus 3i times 5 plus 7i equals a plus bi, then a plus b equals what? Um, I like to FOIL these as well, but I don't actually find out what a plus bi are. I kind of just find a plus b like as I go. So 1 times 5 is 5, and then negative 3 times 5 is going to be minus 15. 1 times 7i, so that's going to give me a plus 7. And then negative 3 plus 7i will be negative 21i squared, which is going to be just plus 21. And so in the end, this is just going to give me 18. Nope. Wait. Yeah, 18. Okay, we're on to the fourth column. Okay, this is when they start getting a little trickier. Okay, the probability of drawing a prime digit from the set of positive digits is what? Okay, so the positive digits go from 1 to 9, so there's 9 of those. And how many primes are there? Well, you got 2, 3, 5, and 7. So this is 4 of them. So the probability is just going to be 4 nines. Okay, number 60. Cube root of this huge thing. So, if you have a cube root, unless I've taken a cube root of 2000, right? I can rewrite this as 2 times 10 to the third, right? Which would be the same thing as the cube root of 2 times the cube root of 10 to the third, which is just going to be 10, oh, forgot the 3, which is going to be 10 times the cube root of 2. So because it's an estimation, I can kind of do this for these kind of questions. So for like each group of 3, except for like the one all the way on the left, I can kind of just approximate it as all zeros. So it's going to be close to this. And so for each group of zeros, so 1, 2, 3, 1, 2, 3, because that can come out as 10, that's going to be an additional factor of 10 that I'm going to have here. So when I'm looking at this, I'm looking at my 202, and I'm trying to think of cubes that are close to 202. So 5 cubed gives you 125, and 6 cubed gives you 216. So I'm going to say that cube root of 202 is something like 5.8. Yeah, something like 5.8. And then if I have these additional 10s, right, that's going to simplify to 580. Let me double check that this is in the range. Oh yeah, the actual answer is like 587. Yeah, we're like right there. Okay, 61. 12 times 6 factorial minus 32 times 5 factorial equals what? Okay. So what I'm probably going to do is, so we have 12 times 6 factorial. What I can do is move this 6 over. And what I mean by that is something like this. Right? Those are equivalent, right? 6 factorial is the same as 6 and then times 5 times 4 times 3 times 2 times 1. So if I do this, right, that gives me 72 times 5 factorial. And the reason I've done this, oh, my pen is struggling a little bit. And the reason I've done this is because now what I can do is factor out a 5 factorial to get 72 minus 32. Okay, I know 5 factorial is 120, or you should have it memorized. And then 72 minus 32 is just 40. So the product of these two is 4,800. Okay, 62 is a trig identity. Let's see. Yeah, if you have the cosine of A times the cosine of B minus sine of A times the sine of B, this is the same thing as the cosine of A plus B. So if I add these two, what's pi over 6 plus pi over 3? Okay, it should be pi over 2, right? And then the cosine of pi over 2 is just 0. Harmonic mean of the roots of x cubed minus 6x squared plus 11x minus 6 equals 0. Okay, so here's what you do. You take the constant term, you divide it by the x coefficient, then you multiply it by the highest exponent. All right? So you get negative 18 over 11, and in the end you just multiply it by negative 1. So our answer is going to be 18 over 11. Okay, 64. Let the determinant of 1, 3x negative 5 equal determinant of 2x negative 4, 6. Find x. So this one is just a little bit to hold in your head. So if I'm finding the determinant, right, you basically like multiply diagonally and then subtract, right? So the determinant of this one would be negative 5 and then minus 3x equals 12 and then minus a negative 4x. So solving for x should give me negative 17 over 7. I think. Yeah, negative 17 over 7. Okay, if the fourth term of the expansion of 2x plus 3y to the fifth is c x to the a, y to the b, then a plus b plus c equals what? Okay, so we really just have to find c, because it's a fifth degree expansion, all the terms, it's going to be like x to the fifth, and like x to the fourth, y to the first, and then x cubed, y squared. And so your two exponents, your a and b, these are always going to add to 5. These are always going to add to 5. So we just have to find c and then add 5. So the way that I like to do this, the fourth term, for the fourth term, all you do is I subtract 1, and then that's my y exponent, and then my x exponent is just going to be 5 minus that. Remember, they always have to add to 5. So x squared y cubed. So to find this coefficient, here's what you do. This is the formula. I have to do either 5 choose 3 or 5 choose 2. It doesn't matter which one. I'll do 5 choose 2 just because it's smaller. Or the 2 is smaller. The value is the same. And then I say, okay, I have a 2 right here as my x coefficient. And since I have the x squared term, I'm going to square that. And I have 3 for my y coefficient, and I have cubed here, so I'm going to cube that. So 5 choose 2 is 10. 2 squared is 4. 3 cubed is 27. So multiplying all these together, I get 1,080. 4 times 27 is 108. Times 10 is 1,080. And then plus my 5 gives me 1,085. Okay. Xy equals negative 4 and x plus y equals negative 3. Then x cubed plus y cubed equals what? Okay. So we have to use some factoring rules here. So the expansion of x equals y cubed looks something like this. Okay, so we already have x plus y, which is negative 3. It's this part that's a little bit tricky to find. So here's how you do it. If you take x plus y squared, right, this is going to give you x squared plus 2xy plus y squared, which is almost what we want. We just have 3 extra xy's. So that's a pretty easy fix, right? I'm just going to subtract 3xy from both sides. Right? And there I have it. So to find this value, x plus y squared, negative 3 squared is 9, minus, I'm running out of space here. So x plus y squared is 9, and then minus 3xy. So xy is negative 4, so 3xy is negative 12. So minus negative 12 will be plus 12. So this is going to end up being 21. And then it's multiplied by x plus y, which is negative 3. This gives us negative 63. Okay, 67, 0 plus I to the 26th. Okay, so obviously the 0 doesn't matter. So this is really just asking what's I to the 26th. If you didn't know, the powers of I actually oscillate. So like I to the first is I to the squared is I squared is -1, I cubed is -I, and I to the fourth is 1. So you can imagine if you multiplied by I again, right, I to the fifth would just be I. And so you basically just have to find what's the remainder when 26 is divided by 4, right? That's just going to be 2. And so the answer is going to be I squared, which is -1. All right, a triangle has sides of 3, 6, and x. X plus 1 has to be greater than what? All right, so this is like a use of the triangle inequality, right? Where if you have two sides, or if you have the three sides, you know that a plus b always has to be greater than c. So that would mean that 3 plus 6, let's see, 3 plus 6 has to be greater than x, but okay, that's not the right form. We want x on this side of the greater than sign. Okay, so I'll say this. I'll say 3 plus x has to be greater than 6. This is called the triangle inequality, by the way. If you want to look this up. There's actually a lot of really cool applications of this inequality. But you get 3 plus x is greater than 6, so x has to be greater than 3, right? And so then x plus 1 would have to be greater than 4. Okay, let's see, 69. Okay, we got a pattern, and I'm not seeing the pattern. What's the pattern? Okay, it's not going to be Fibonacci. It's not going to be Fibonacci. Primes? No. Oh, no. Actually, let me just start writing some stuff. Maybe I'll stumble upon it. Okay, so here's primes. Here's composite. I think that's it. I'm not sure what this pattern is. Maybe I'll think of it and come back to it. Okay, 70. 62.5% of 24 yards is how many inches? So 62.5%, that's just 5/8. And then 24 yards to inches will be 24 times 36. Well, 24 times 5/8 is 15. 15 times 36, if we use double and half, is the same thing as 30 times 18, which would be 540 inches. Okay, on to the final stretch. Okay, 71. If f of x equals x cubed plus 6x squared plus 12x plus 8, then f prime of 1 equals what? So I'm just going to take the derivative of this equation, right? Derivative of a constant goes to 0. And if I plug in 1, that's just 3 plus 12 is 15 plus 12 is 27. All right, 999 times 14 over 37 times 16 over 27. Well, I know that 111 divided by 37 is 3. And so 999 divided by 37 is 27. And then I can cancel this. 27 divided by 27 is 0, or is 1. And I'm left with just 14 times 16, which is the same thing as 15 squared minus 1, right? Difference of squares. Maybe you've seen this. Instead of 14 times 16, I can write it like this. 15 minus 1 times 15 plus 1, which is the same thing as 15 squared minus 1, which is 224. All right, 73, find x if 7 is less than or equal to x is less than or equal to 13. if 3x plus 1 is congruent with 35 in mod 7. Okay, so if it's congruent with 35 in mod 7, that means it's also congruent with 0, because 35 is a multiple of 7. Okay, then I'm kind of just going to start adding 7s. Okay, if I add 7 here, because that would be the same thing, right? Having a remainder of 0 and a remainder of 7 would be the same thing if you're dividing by 7. So 3x would equal 6, so x equals 2. Oh, well, that's not in our range. Okay, what if we add another 7? Well, 14 minus 1 is 13, which isn't divisible by that, so that doesn't work. What about 21? That doesn't work, because 21 minus 1 is 20, divided by 3 doesn't come out nicely. What about 28? Okay, 28 minus 1 is 27, and then divided by 3, that gives you 9, which is, in fact, on this range. Nice. Okay, the graph of y equals x plus 2 over 5x squared minus 1 has how many asymptotes? Okay, let's see. So, we'll start with vertical. We're going to have 2 vertical asymptotes, because this down here was going to have 2 roots, and therefore two ways that the bottom can be 0. So we've got 2 vertical asymptotes. We've only got 1 horizontal asymptote, because like if x goes to infinity or x goes to negative infinity, either way it's going to make the bottom really, really big, which is going to make the whole fraction close to 0. So it's just, and it doesn't have any slant asymptotes, because the only way you can have slant asymptotes is if the degree on top is 1 more than the degree on bottom. So we're just going to have 3. All right, finding the inverse function of 11. So when you get something like this, you can just set this equal to 11, and then solve for x. So 11 minus 7 is 4, 5 times 4 is 20, 20 minus 3 is 17, so this is just going to be 17 over 2. Limit is x approaching infinity of sine of x over x. Well, the sine of x doesn't really even matter, because I'm looking at this x, and if the bottom is infinity, then it doesn't really matter what this is. It's gonna make it really, really small, so it's gonna approach 0. Okay, 77. Integral from 0 to pi of sine of x. Okay, so the integral of sine x is negative cosine x. That's just one you would have to have memorized. And then evaluate it from 0 to pi. So let's see, cosine of pi is negative 1, and cosine of 0 is just 1. So this is just going to evaluate to 2. Okay, so the sum from x equals 1 to 3 of negative x to the x. So this will be negative 1 to the first plus negative 2 squared plus negative 3 to the third. Right? Negative 1 to the first is just negative 1. Negative 2 squared is 4. Negative 3 to the third is negative 27. So here I'm just going to get negative 24. Negative 24. Okay, for the next one, this one's kind of tricky actually. Just because you have some square roots and you have to memorize some square roots. But if you just have these memorized, it's not too bad. So square root of 3 is about 1.73. Square root of 5 is about 2.23. And square root of 7 is like 2.65. Alright, so if I add all these together, 1.73 plus 2.23 gives you 3.96, which is basically 4. And then 4 plus 2.65 gives you 6.65. And then subtract that 0.4 that we had from before, so 6.61. And so to the 10th place, that's just going to be 6.6. I really wish that there was an easier way of doing ones like 79, but I've yet to figure a way out. Alright, and then our number 80 is actually pretty easy. You just have to use the conversion factor that 15 miles per hour equals 22 feet per second. Okay, so if you have 75 miles per hour, that's 15 times 5. And so to get the feet per second, you just multiply that by 5, which is 110. Okay, that's about it. That's the whole backside. We went through that pretty quick, but it was mainly because we didn't have a whole lot of chat participation. Hopefully, we can get more of that in the future. But hey, yeah, if you guys have any questions, feel free to post them. Yeah, feel free to post them whenever. Post them in the chat. If I don't get any, if I don't get any soon, then I'm just gonna go ahead and end the stream, and you guys comment on it later. You can go back and watch it later. All right, I'm gonna call it good. All right, thank you guys for watching. That's the end of the stream. See you guys.